All right, the last conic section that we're going to talk about is a hyperbola. So a hyperbola has two pieces to it, two kind of U-shaped pieces. They look kind of like parabolas, but they're not exactly the same shape. But they are still U-shaped pieces, but there's two of them. So if we look at the standard form of the equation for a hyperbola, if you notice, this equation is almost identical to the equation of an ellipse. The only difference is that this time we have a subtraction sign between the two fractions instead of addition. That's really the only way that you can tell by looking at the equation whether you have an ellipse or a hyperbola. So with hyperbolas, there are two pieces. So from this picture up here, you have a piece opening up and a piece opening down. And then if you have, you could always hold it sideways and have a piece opening left and right. So here's what the two different kinds look like. So if you have x squared first in your equation, then this is opening horizontally, where you have your two curved pieces, your two U shapes, opening to the left and to the right. In the equation, if y squared is first, then that's when your two U-shaped pieces are going to open up and down. So that's how the graphs of these hyperbolas are going to look like. Another thing to notice about the graphs of these hyperbolas is that they have two asymptotes. So remember when we were graphing rational functions in advanced algebra last year, you had asymptotes that the graph got really close to but didn't touch or cross. So with hyperbolas, we have these two asymptotes that we're going to draw first, so that way when we draw in our U, we can get really close to those asymptotes, but we're not going to actually touch or cross them. They're going to be our boundaries or our guidelines to help us draw the graph a little more accurately. So a lot of this, the way that we're going to go about graphing this, is going to be very similar to how we did ellipses, because we're going to be counting from a center point up and down and left and right, just like we did with our ellipses. And the amount that we're going to count is found the same way that we did with ellipses. A squared is the bottom number here, so if we square root that to just get a, that's going to tell you how much to count left and right from that center point. The square root of this b squared number is going to tell you how much you're going to go up or down. So it's going to be very similar to what we did with ellipses. The center of the hyperbola is going to be exactly the same as what we did with ellipses. It's h and k. So h is inside the parentheses with the x, k is inside the parentheses with the y, and we take the opposite of both those numbers. For the equation where y squared comes first, be careful, because h is with the x, so it's the second one this time, and then the k is still with the y, so it's first this time. So be really careful. H and k are in order when x is first, but when y is first, h and k are they've been switched. So just be really careful when you go to write down your center when you have it backwards like this, where y squared is first. Just like with our parabola and with our ellipses, we have a focus. Actually, we have two foci, and it's just like with the parabola where it's going to be on the inside. These pictures don't show the foci, but it's going to be inside the U's along this line here. So you could have a focus here on the inside of this U, and you would have another focus over here inside that U. When they open up and down, they're still going to be inside the U's. You're going to have one above, and then you're going to have one below, inside those U shapes. So we're going to have to find the two order pairs for those foci as well. And we're going to find it almost the same way we did with ellipses. Instead of doing the square root of a squared minus b squared like we did for ellipses, this time we do the square root of a squared plus b squared. And this is going to be the value that we add and subtract from the center point in order to get those order pairs for the foci. So you can see here we add and subtract that value, c is what they call it here. We add that and subtract it from the x coordinate when x is first. When y is first, we add and subtract that c value to the y coordinate of the center. So let's actually do some examples. So we already did some in class. So let's look at some that we didn't do. So this first example here, this number 2, we have y squared first. So we're going to be looking at this equation here where y squared is first. So it's vertical, so we know that when y squared is first, we know it's going to be opening with our u shapes up and down like this. So that's one thing to kind of think about off the bat. So I always find my center first, h and k. So my center for this one, remember h is with the x. So this time it's in the second set of parentheses. And we always take the opposite for h and k for the hyperbola and the ellipse. So the opposite of a minus 3 is a positive 3. So that's the x coordinate. And then here the y doesn't have anything being added or subtracted to it. So this is y plus 0 or y minus 0. So the y coordinate on my center point is 0. So at positive 3, 0, that's where the center point for this hyperbola is located. So you can go ahead and graph it. Positive 3, 0 right there. So then this a squared and this b squared, that is going to tell us the horizontal or vertical distance from the center to the edge here. So if you see from the examples we did before, we're going to create this little ghost box in order to figure out where our asymptotes are going to go so we know exactly where to draw the u's. So the number underneath the y squared here is 25. So if you square root that 25, you get that a is 5. And then if b squared is 4, then square root it, so b is 2. So instead of remembering that a and b go up or down or left or right, I always just look and see what it's under. So the 25 was underneath the y. So we know that the y goes up and down, that y-axis does. So that 5 is how much I'm going to count up and down from my center. So I'm going to go 1, 2, 3, 4, 5. And then I'm going to go down 5. 1, 2, 3, 4, 5. So since that number was under the y, that's how I knew I needed to count that up and down. Under the x, we had the 4, which is 2 here. So we're going to go left and right, 2 spaces. So now I'm going to create a box out of this. And this is kind of a shortcut cheating kind of way to graph the asymptotes of the hyperbola, because the asymptotes are going to go straight through the diagonals of this box. So I'm trying to make it as straight as possible here. So the asymptotes have to be drawn, and by drawing this little box, it kind of gives me a shortcut for getting those asymptotes in the exact right place. I'm not going to make you find the equation of the asymptotes. As long as they are drawn properly, then you're good to go. And then because y squared is first, we know that the u's are going to go up and down. So this point right here that we already have plotted is where we're going to start drawing our u shape up. And then this exact point here is where we start drawing that u shape down. So you can kind of think of it as like the vertex of your parabola, even though these are not parabolas. Okay, so you have your hyperbola drawn. The last thing you need to find are the foci. We need to find the order pairs for the two foci. So if we look at our notes here, the foci for this one, we're going to find the value of c and just add and subtract it to the k or the y coordinate of our center in order to get those order pairs. We're going to leave the x coordinate the same. So we need to find c. Well, to find c, it's just the square root of a squared plus b squared. So to find c, we're going to do the square root of a squared is 25 plus b squared was 4. So this is the square root of 29. So to write the foci, or, you know, if we want to do just do some rounded decimals here, the square root of 29 is about 5.39 or 5.4 if we want to round it there. So to find our foci, looking at our notes, remember you can see the h stays the same. So our center point, the h is 3. So the x coordinate of both of our foci is going to be 3. And then we need to add and subtract the c value that we found, the 5.4, to the k, which is the y-coordinate of our center here. So we just need to take 0 plus 5.4, which is 5.4, and we need to do 0 minus 5.4, which is a negative 5.4. So you could plot those points. Go to 3, positive 5.4, so it's just above there. And then go over to 3 and down to negative 5.4, which is just down here. So there you have it. We have graphed our hyperbola with both its asymptotes, its opening in the right direction, and we have found both of the foci. So let's do one more example where let's do x squared is first this time. So when x squared is first, we do pretty much the exact same thing. It's just our u's are going to be on the left and the right this time. So find the center first, which is h and k. Well, if you notice, there's nothing being added or subtracted to the x, so our x-coordinate is 0. There's nothing being added or subtracted to the y, so our y-coordinate is 0. So this one's centered right at 0, 0. Underneath the x squared, we have 25. So the square root of 25 is 5. Under the y squared, we have 16. The square root of 16 is 4. So because the 25 was under the x, that's horizontally. So we're going to go horizontal 5. 1, 2, 3, 4, 5. To the left. 1, 2, 3, 4, 5 to the right. Underneath the y squared was 16, so we square rooted that and got 4. So that means in the y direction, or up and down, we're going to count 4 from the center. 1, 2, 3, 4. 1, 2, 3, 4. And then we're going to do a shortcut and create a box out of these in order to figure out where the asymptotes need to go. So remember, the asymptotes need to go straight through the diagonal of this box. And we need to extend it all the way out. So then make it as straight as possible. Once you have your two asymptotes, then you can draw in your u's. Remember, since x squared is first, we're going to do it open horizontally this time. So we're going to open on the right and on the left. And so remember, we start at that point we have plotted, and we're going to curve outward all the way to the asymptote. We're going to stay right along the asymptote, but never touch or cross the asymptote. The last thing we need to do is find the foci. So again, we find c, which is the square root of a squared plus b squared, so 25 plus 16. So what's that? The square root of 41 and the square root of 41 is about 6.4. So because we're opening horizontally this time and x is first, we're going to actually add 6.4 to the x coordinate of the center this time. On the last example, y squared was first, so we added 5.4 to the y coordinate, and the x stayed the same. So when x squared is first, we're going to add to the x coordinate, the y coordinate will stay the same. So the foci on this one, the y coordinate is going to stay 0. And the x coordinate, we're going to add and subtract 6.4. So 0 plus 6.4 is 6.4. 0 minus 6.4 is a negative 6.4. So at 6.40, about there is our first foci. And negative 6.40 is about right there. That's our other foci. So hopefully that was helpful. If you still have questions, shoot me an email.